Sorry, my son interrupted a bit, so let's begin again. So now the signal state, so I'm going to write the signal SQL database, this signal RDID, enter 1150, and now enter, it's basically saying us alchemy, but yeah, that's fine. Okay, now we also need to, maybe for example, we just want to get that and one is for green. I just want to take the time of the beginning of the time. And these study idea, non-idea iterations are for the unique number for this iteration and run ID for this scenario. Inside controller number, we maybe want to add this one too, as our different controllers can have different for different history. So we need to identify that. So dot sc, maybe I will pick the 4430 intersection number. It is basically, I think, intersection number 4433. We can check it from here. Yeah, first intersection and controller number. And you can also get actually convert this to a numpy array. The how we can using numpy and pandas. These are not part of this tutorial. This is how we can use these things. The step should be 0. So now, okay. So use these numbers, and now maybe we can create a data frame from here. Right. Now first check that if our length of y BOZ, we are actually going to create a data frame where the first number would be BOZ and the second one would be EOZ. So if the first element of BOZ is higher than the or larger than the EOZ's first element, then it does not make any sense. So we want to Okay. Similarly, we want to end with a higher EOZ than the BOZ. And 4 should be less than this number. So we will basically write this here. So this is saying BOG's last element is less than EOG, which is what we wanted, but if that is not the case, like BOG's last element, then fine. Okay, something is wrong. First element, okay. Oh, it deleted everything. Wrote this again. Oh, that's why. We didn't sort this number. So if I sort this values, so we don't need to sort here. That was the case. Okay, yeah, now it should work. Now fill the data frame. Yeah, now we do have a fine data frame explaining that started at 10.9 and ended. Okay. Now remember that this so our ID number for this intersection is here like 630. Is this single group number 2 or single group? So then that is not the direction we are looking. We are looking for this number 2. And one here is basically our travel time section. So this should be 42. So now we can go like one run ID and one iteration. We don't need to worry about that. If we will worry about that, but that is not the case right now. And our target travel time section is 642, as I have seen from here. It is 640, only that one. So is like don't have any. Just check that there is no controller number in the travel time section. This is all only the vehicle ID number, only like the travel time section number. So number 42, this is our target number, and we can print this, or we can actually just keep this columns that way that are going to be useful. Okay, so these are the, now this time is actually basically the time when the vehicle cross this section in here. The total travel time is basically this number here. So the start time when this vehicle cross this first section is basically time minus this travel time. So we can add that start time minus travel time. Copilot will get that automatically. Okay, so now we have this start time and end time. Now we want to check if this vehicle actually when it is green or not, maybe. So we can do that using this technique because start time is 4:28. So this vehicle was here when and from here to this distance we can use this ruler tool and go to all the way up to 950 feet to the stop bar. Okay, and our simulation speed here is like, do you have any desired speed distribution? So there is something called I'm basically looking where they define the speed. Other ways to define this thing, and I'm looking for that. Right, right, there should be some, So for now, let's assume that our speed limit is 45 and the speed was like 950s. Come here and like 9 5 mph 1.47 to convert feet to second, and it is 18.5 seconds. So basically, if we just add now 18.5 seconds, vehicle's travel time at the stop bar. Now we can check basically if the vehicle arrived at single gear or without or end of this period, and this way we can actually idea if the vehicle at green or at red. Okay, we can do this within March, and we are going to use the PD March as of, which actually have this file like the backward forward where the one March as of. The first database is going to be TTBA. Sort this ttb.sort values by extra time, that's fine, plus 2. And these data are already sorted, so I don't need to worry about that. Stop bar time. Okay, let's check first which one, what it gives us, and then we will check. Backward means this time should be larger than this one. Which are let's check 97, and the stop bar time is, yeah, this one is actually larger than this one. This one is larger. Stop bar time 186. Okay, now check March period dot GOG is less than March period dot per time. Okay, now check if there is any case where it was wrong. Condition check. Yeah, there is no record. So we pass this test basically, as simple as that. And now we want to check if the stop bar time is actually less than the end of green. If it is less than end of, arrival on green is okay. Now we should have data where yeah, you can see that there is so true false, so all of them are possible. So maybe we can check it. Go to log here dot aog is equal to 1. On 337 in between 320 and 369. Yeah, there are some cases. We can check the length divided 34, and that is total arrival on green, and total occurrence or total number of vehicles is going to be much here. Okay, and now your percentage in green is like this 34%, 35%. So yeah, this is how we can actually calculate percentage on green and extract data from using the SQL server. Okay, so that's it for today, and I will update this in the tutorial folder or in the YouTube. Thank you.